Hello everyone. In this video, I'm going to demonstrate how I use a temporal convolutional network or TCN to predict daily temperatures in Sri Lanka. The workflow includes loading and cleaning the dataset, preparing the features, building the TCN model, and finally evaluating how well it predicts future temperatures. First of all, I'm importing important libraries including NumPy, Pandas, Matplotlib, Seaborn, and sklearning. Then I'm set up the plot using Matplotlib. Then I'm going to extract Sri Lanka weather dataset into my Google Colab. I use read CSV function from Pandas to read CSV file from my Google Drive. After that, I print the shape of the dataset, and using head function, I quickly look at data and understand its structure from first 5 values. In this part, I'm cleaning the dataset by removing any rows that contain missing values using drop NA function. And after that, I remove columns that are not numeric, such as city, country, latitude, longitude, elevation, time, sunrise, and sunset. Here I'm selecting temperature mean as a target variable, which means this is the value my model will try to predict. First I check if the column actually exists this dataset. If not, it raises an error. Then I separate data into two parts, X and Y. X contain all the input features and Y contain all target column we want to predict. Then I'm using min-max scaler to normalize the features. After that, I'm splitting my dataset into two parts, train and test. For the train, I'm using 80% of my dataset, and the rest of the 20% I'm going to use for the test. This is my training shape and the testing shape. Now I'm going to build my TCN model using a sequential model, which allow me to stack layers one after another. This is my TCN layer, and I'm using relief as the activation function. For the optimizer, I'm using Adam. Here's my training part of my model. I'm using 50 epochs and 32 as a bed size. After that, I save my model in my Google Drive. For the future purpose, I can load this model from my drive from using this code segment. Now I'm going to evaluate my model performance by using test dataset. So I'm going to evaluate function for this. And I'm going to calculate two important matrices, R squared and root mean squared error. By looking at the result, we can guess that the predictive and true values are in same level. Finally, I visualize the training result to understand how model performed. In here, I compare true temperature values with predictive ones. In here, I display first 100 sample from the test dataset to see how closely prediction follow the real trend. If this two line almost overlap, it means the TCN model is making accurate forecasting.
Good evening. My project focused on time series forecasting using a gated recurrent unit GRU neural network. The specific goal was to build a model that can predict future weather codes based on a sequence of past weather observations. I used a data set of Sri Lankan weather data from this task. Weather forecasting is the classic time series problem where past patterns are used to predict future status. This section covers how how I acquired and prepared the data for the model. I sourced the data from Kaggle, especially the Sri Lanka weather dataset. The code used the Kaggle Hub library to download it directly. The dataset contains 147, 180 entries with 24 features, including daily measurements like temperature, precipitation, wind speed, and our target variable weather code. First of all, I set up environment, install required packages, and after that, I import libraries like pandas, NumPy. I load dataset, replace the path with my file path. There's this one. After that, I explore and clean data. First of all, I check basic info, and after that, check for missing values, drop rows for fill missing values. There's this one. After that, I did feature selection. They have columns as temperature, precipitation, wind speed, and wind gusts. After that, I did normalized min max scaling. GRU models perform better with scale data. After that normalized part, I create time series sequence. GRU need sequential input like past n times and next time prediction. After that, I train test split. Now my data set is fully pre-processed and ready for the GRU model building stage. Build the GRU model, I used TensorFlow Keras to create a GRU-based time series forecasting model for the wind speed. Train the model. I compile the model with the Adam optimizer, popular and event algorithm for gradient-based optimize. The loss function was mean squared error, MSE, which is standard for regression problems. I measured the average squared difference between the predicted and actual values. I trained 50 approaches with the batch size 32. This means the model sees the entire training dataset 50 times and the weight are updated after processing every 32 sequences. The training approaches choose the training data, X training and Y training, and use the test set X test and Y test for validation after each approach and monitor for overfitting. After that, plot training results, visualize how the model performed during training. There's this graph. And after that, I make predictions, use the train GRU model to forecast wind speed on the test set, visualize actual versus predicted wind speed, evaluate model performance. There's this one. Data loaded and pre-processed part, GRU model built and trained, and I predictions visualized and evaluated part is done. Thank you.
Good evening. My name is Rachel, and today I'm here to present you with the weather condition classification function using deep neural network model. So first we have installed all the necessary packages that we need: TensorFlow, Pandas, NumPy, Matplotlib, and JobLib. And this JobLib is used for like saving and loading the trained machine learning models efficiently. And we have also used OS, Sys, Math, JSON, Random. These are basic Python and system libraries that we have installed, and some data science libraries. So scikit-learn models have also been imported. With all of that, we are going to print the TensorFlow version to confirm the installation process. Next, the user can load the CSV files. So then you're going to see after the loading of the CSV files, this is the table that is generated. So as per the CSV file, and then you can have quick sanity checks. So this is going to deliver you a bar chart also that shows the class distribution weather codes respectively to a count and weather code as X and Y axis. Next, you're going to have a train validation and test split. Now, during this section, it's going to generate the categorical columns to you, the numerical columns in here, the trained data, the value, and the test, and the unique encoded classes, as you can see. Next, we have the pre-processing function where we impute, have a scale of the numeric data. One hot encoding happens, and we're going to use categorical cross entropy as our loss function. And yeah, so this is going to print you the categorical columns, the numerical columns, right? And next, we have imported some other libraries like one hot encoder, standard scaler, simple imputer, DOM, pipeline, All these are used for the training, validation, and testing purpose of the data set. So this is where the pre-processing part happens. It shows you the input dimension after pre-processing, the number of classes that are there and everything. Next, you're going to see the DNN model, which is the Keras function. So it will give you a kind of a brief summary stating you the total parameters, the trainable parameters, non-trainable parameters. Then we train the data to run on a 50 epochs. So you're going to see an accuracy and a loss chart. So the accuracy chart gives you the accuracy and the epoch, having the train accuracy, value accuracy as the legend. Same goes to the loss function. It shows you the train loss and the value loss as the legend, having loss and epoch as the X and Y axis. Next, you're going to evaluate the model. Later, you're going to test the accuracy of the model. So this is the accuracy level, 0.78%. This is the classification report that shows you the accuracy macro average, weighted average. And you're going to have evaluation for the saved model. And next, you can see that we're going to generate a confusion matrix. So it shows you the predicted data and the true data, respectively to the weather information. Then you're going to save the model and the inference helper. So we are using a property here called volume to generate this map, and locations are shown by these dots that you can see in the screen. And next, we are going to generate kind of a legend. So as you can see, the temperature scalar is there, ranging temperatures from coolest to hottest. That goes under this category. So you can see average temperature from being most cool to most hot as red. So it gives you an idea regarding the temperature. So color is shown by the temperature, size of the rainfall is shown here as per this function, right? Radius scale of the rainfall, removing unnecessary outliers and so on. So adding circles and pop-ups for each city. Circle markers are given for the row of latitude and longitude, etc. So with that, it comes to the end of my function. Thank you.
Hello everyone. Today I'll be presenting my project on temperature forecasting using an LSTM neural network. The goal of this project is to predict the next day mean temperature using weather data from the Sri Lankan weather prediction dataset on Kaggle. Let's walk through the main parts of my Jupyter notebook. First, I imported all the necessary libraries including NumPy, Pandas, Scikit-learn, TensorFlow. Then I loaded the dataset and removed any rows with missing values to ensure clean data and for training. Under feature selection, I chose only the most relevant weather columns such as temperature, wind speed, rainfall, and solar radius, since unrelated columns like city and country do not help the model learn patterns. Then I applied min-max normalization to scale all numerical values from 0 and 1. This step is essential for LSTMs because they are sensitive to input magnitude. LSTMs learn from sequences, so I wrote a custom function to create 30-day sliding window of data, where each sequence of 30 days predicts the next day's temperature. Then I split the dataset into training and testing sets using an 80:20 ratio. LSTM model is built using TensorFlow Keras API. It consists of two LSTM layers with 64 and 32 units, each followed by dropout layers to prevent overfitting, a dense layer with 16 neurons, and a ReLU activation process the learned features. And the final output layer predicts the next day mean temperature. I compiled the model using Adam Optimizer with mean squared error as the loss function and mean absolute error as a metric. The model is trained for 50 epochs. The evaluation model performance is displayed in this Jupyter notebook. In summary, this LSTM-based approach successfully captures temporal patterns in weather data and provides accurate temperature forecasts in the future. I plan to extend this work by including additional meteorological variables or experimenting with attention-based LSTM models to improve accuracy. Thank you.